So now what we're going to be doing is sketching graphs that are in the form of y equals x minus h all squared plus k. So what we like to call this is actually our turning point form. So from this, I'm not sure what just happened there, so we can actually identify our turning point. So I've written that the turning point can be found by looking at the value of h and the value of k. Now the reason that h is not actually negative in our turning point is because if I went to solve for x, because I'm trying to find the x value, basically what's going to happen is the following, which is why h is positive. And then we've got the value of k, it's positive, and that's consistent with how it's represented in the general form. So what this translates to is that the graph has moved h units along the x-axis and then k units along the y-axis. Now, if I'm to sketch, so let's just go to my Cartesian plane. I'm just going to roughly sketch. Oh, that is shocking. Try that again. So here I'm going to sketch the quadratic y equals x squared. Now, I'm going to sketch basically the general equation of the turning point form on this same set of axes, just so we can see what's happened. So I'm just going to at random pick a point. All right, and let's just assume that this, for the purpose of this, is h, and this value is k. Again, I might just rub out that. That does not look parabolic at all. Right, so again, now what I've sketched here is y equals x minus h all squared plus k. So our turning point here is now h and k, and what this means for us, is that the graph has moved from the green to the pink. It's moved h units across, and then it's had a vertical shift of k units up. So I should have probably drawn that there, not down there. So again, going along the x-axis, we've moved positive h units across, and then moving up the y-axis, we've moved positive k units up. So that means that the turning point has gone from 0, 0 to hk. So now let's have a look at some examples with actual numbers in them, and hopefully this will start to make a lot more sense. So looking at the following equation we've been given, we can identify a turning point at 2, 6, and that's because x minus 2 equals 0. So solving for x, we get x is equal to 2. Now, if I plot this on my actual Cartesian plane, 2, 6 is about here. So looking at this, I can make quite a number of educated guesses, in that I may not actually have any x-intercepts. I'll definitely have a y-intercept, and we know that because A is positive, or this graph is actually positive, we're not going to have any reflections, which means chances are we're not going to have any x-intercepts at all because it's a minimum graph. So let's prove this using maths or using algebra and check and see whether or not we will have any x-intercepts. So recall that to find our x-intercept, we need to let y equal 0. So we've got 0 equals x minus 2 all squared plus 6. Taking the 6 to the other side makes it negative. So we've got x minus 2 all squared. Now, we can't actually square root the negative 6. So what this means for us is that we will have no x-intercepts, because no possible solutions exist. So chances are now my graph is definitely going to have a y-intercept, but it definitely will not touch this x-axis. So let's find our y-intercepts. So subbing 0 into the equation, I'm going to have y equals 0 minus 2 all squared plus 6. So y is equal to 4 plus 6, y is equal to 10. So I'm going to have a y-intercept at 0, 10 up here. So now drawing my parabola, and feel free to substitute another value in if it's going to help guide your the way your parabola looks. Excuse my blunder. So for example, if I substituted 5, x equals 5 into it, I'm going to have y equals 5 minus 2 all squared plus 6. Actually, that might be too big of a number for us to work out because my y-axis doesn't extend that far. Let's just do 3. So we've got y equals 3 minus 2 all squared plus 6. Y is equal to 1 plus 6, so y is equal to 7. So when x was 3, y was 7 up here. Oh, that's close enough. Ooh, that is not great. There we go, that's as close as I can get it. So again here, this is y equals x minus 2 all squared plus 6. So we can see here that the graph has a turning point at 2, 6. It has a y-intercept at 0, 10. And again, what this has told us is that the graph has shifted 2 units across, then 6 units up along the y-axis when compared against the original y equals x squared graph. So now let's do another example, and this time what we should end up with is some x-intercepts, just to give you another idea of how the turning point form looks or works out. So here we can identify a turning point at 2 and negative 4, noticing that here in front of the 4 is that negative. So let's find our x-intercepts. So solving for x here, we're going to do 0 equals x minus 2 all squared minus 4. Taking the 4 to the other side, or the negative 4, sorry. I'm going to have that square root of 4 equals x minus 2. So that's going to give me plus or minus 2 equals x minus 2. So x minus 2 can equal positive 2, or x minus 2 can equal negative 2. Now solving for x, I'm going to get x equals 4 or x equals 0. So what this means for us is that this particular graph will intersect when x is equal to 0 and when x is equal to 4. So plotting my points there and there, I had a turning point at 2 and negative 4. So that means my graph is going to be down here. And let's work out our y-intercept real quickly. So we're going to have y equals 0 minus 2 all squared minus 4. Y is equal to 0, y is equal to negative 2 all squared minus 4. Y is equal to 4 minus 4. Therefore, y is equal to 0. So that means that this particular graph will, has a y-intercept at the origin. So now if we go to sketch this, we will end up with a quadratic that's going to hopefully look as parabolic as possible. So there's our parabola there. Again, it's going to look a lot different depending on the way you scale your graph and how big it is. I've just used a scale I found online, so it's not going to look as perfect, but we're going to try. So again, our turning point here is now 2 and negative 4. We've got an x-intercept at 4, 0 and 0, 0. And that's it. So hopefully now you're able to grasp sketching graphs in the form of y equals x minus h all squared plus k. Keep in mind it is one of the nicer and more easier quadratics, I guess, to graph, because you can identify your turning point straight away. There's no need to work it out. You just need to make sure that you're very careful about solving for your x-intercepts and solving for your y-intercept where possible, just because you could end up with, especially with your x-intercepts, where you could have a situation with no x-intercepts, one x-intercept, and two x-intercepts.